remains in the sediments in different form that can be reconstructed. If we can see environment, landscape, and artifacts, why not we reconstruct the past human behavior? But somehow it's not happening. In prehistoric research, it is already done in the other countries. Somehow in Indian context, we are still working with the artifacts, nothing beyond that. That's one of the reasons why when you teach to the students about the prehistoric archaeology, they get bored. They must be thinking, is it ends with the lithic artifacts, stone artifacts, nothing beyond that? We'll have to do only with the stone tools, collect the stone tools and classify it? No, that's just a small aspect of the whole prehistory. You'll get the brief idea what the objective of this prehistoric research today. Objective is to understand the past human behavior and reconstruct the past lifeways. It's not only the stone tools. Then beyond lithics, we have done enough work. Every day some more artifacts and more artifacts, more and more sites. What does it mean? Hardly says anything. Some of the archaeologists, way back in 30, 40 years back, when they are doing some sort of a research, classifying the artifacts, they called it laundry list. What do we mean by a laundry list? The listing of your clothes. That is what we are doing. We'll have to go beyond the laundry list. Some of the well-known anthropologists, archaeologists, Desmond Clark, they say, no, these lithic artifacts are just the skeleton. We'll have to put flesh and blood to reconstruct the lifeways of prehistoric man. Then many a times what happens? Our stepmothers attitude towards the lithic debitas. When you collect the artifacts from any of the sites, we get beautiful hand access cleavers, finish tools, and lot of these small debris. And we keep all these debris aside and look into these finish tools and say that, oh, I have got some beautiful tools with me. Do you think that it says something? Or we'll have to go beyond that. Your debitas, it has been realized, your debitas, the byproduct of these tool manufacturing system. And these debitas, they tell more stories about the human behavior rather than the finished artifacts. Then present holds the key to the past. Realizing this fact, way back, like Binford, something like 30, 40 years back, he said, if archaeologists have to work really in the field and reconstruct the past, keeping aside anthropology, they cannot do anything. So one of the seminal papers by him is called Archaeology as Anthropology. They told the archaeologists, don't feel that you are everything. You make your discipline like anthropology. You can go ahead. From that day, which you call a new archaeology concept, we have really, unless we say someone has got a background in anthropology, cannot simply work in archaeology. So because we have not seen those past, we can understand through analogy, we can understand the present day communities, and through analogy and the different methods, we can reconstruct the past. So leaving aside anthropology, there is no way out for archaeology. Then we have got a lot of evidence. When you go back in time, the evidences become small and small, very meager. Because through passage of time, many of the evidences are lost forever. But like a forensic scientist, our job should be very, very methodical. We go more back in time, we'll have to be more and more methodical because our evidences are less. We'll have to collect very, very meticulously and piecing together all the evidences, reconstruct the past. That should be there. Then finally, error. I do not know what happens in other branches of anthropology. In archaeology, like all other sciences, error is a must. We'll have to realize we cannot, because we are dealing with social science, behavioral science, and we cannot say that there is no error. What I say, it's 100% correct. Even physics, they accept what's the error. So this error aspect has now been realized in last 30, 40 years, which we call site formation processes, post-depositional processes. The day the artifacts are discarded, from that day till the day the archaeologists recovered it from the sediments, there are a lot of changes has taken place. And we archaeologists have to understand those changes. If you know what are the factors responsible for the changes and why the changes has taken place, then you know the error, and your interpretation will be much better than without recognizing the errors. Now I'll take you to the area where doing some sort of investigation of Acheulean sites. And now I'll pass through a number of slides. You'll see how we investigate, then how we reconstruct some of the behaviors, human behaviors, how that is reflected from the sites, from the artifacts, from the landscape, how we interpret. I'll give you many of the examples. Now, this is central India where we are working, and it's in Madhya Pradesh. And this area was investigated way back in 70s, nearly 50 years back. And after that, it was almost abandoned. And we took up, realizing the fact the number of sites were reported. Now, this area, if you see, this is the area where we work. It's a very small area away from the river, because river banks sites are mostly disturbed, which you call as secondary sites. These are away from the river banks on the foothill. Hardly any disturbance has taken place. Now, these hills are the fringes of Bindians. Bindians are the particularly sandstone and quartzite formations, and whereas these valley floors are of Deccan trap, which is a basalt. These hills are of Bindian hills, sandstone quartz. This is a source of material for the Acheulean people. And Narmada is down below, and Betwa goes to the top. Now you can see this area, this valley floor, because you know that Deccan trap basalt gets weathered very, very fast and gives rise to a black sediment, very fertile, rich in clay, and these are all cultivated. And these are the Bindian hills, this side. And this is the hill I'm talking about where we are working. Now, if you see the map, that is the hill which I showed you earlier, this hill. And this is the hill. There are a number of sites on the foothill area, and about 2 kilometers south of this is another group, which is completely in Deccan trap area. Whereas these localities are in the Bindian area, sandstone quartzite source area, source of the raw material. Here there is no source. So how these two area people they are behaving, let's see. Now I'll take to that area. This is an aerial view of the very close to the hill, and there are beautiful sediments trapped, and within the sediments there is something like 10 to 12 meter thick deposit of Acheulean, and this is an aerial view of that valley. And you can see this is a picture from the Deccan trap area, Acheulean sites down south. This is a black sediments, each, and because there is no source of quartzite or sandstone, each of these stones are artifact. See the density. It's littered with the artifacts. Now the frequency is so much there because people do not get, the villagers that do not get any other stones, and all these hand-access cleavers are unusual in shape. They worship in the form of Gwal Baba, some deity which protects the cattle, since they are of unusual shape. So that I am showing it just to make you realize what is the frequency of these artifacts. Now, when you go to any of the sites, we try to see what should you do? Why we are going to investigate an area? So realizing the fact that the area is very rich, what we thought that let's investigate, because this is a very single culture site. We have got only Acheulean settlements. So what is the nature of this settlement? And what is the settlement pattern? Intra and intra-settlement pattern. Within one area, within one locality, and between two areas, between two localities. Then, since there is a very thick deposit, whether there is a change in assemblies, both time and space, then how the transformation has taken place from earlier to later stage. Now I'll take you to one of the localities near the hill. Okay, this is called Tikoda 1, and this is the area, this is a camp area. Now if you see, there are huge boulders on this side, and towards this is the hill, and towards the north is the valley floor of Deccan Trap. Now here is one patch which is very, very smooth and plain, and there is a sediments deposited. And on both sides, there are huge boulders. Now this site was selected for occupation by the Acheulean because this is very smooth, plain, and good for habitation. See their mines. When you go to the boulder area, we do not get the artifacts concentration. So even they are selecting the areas which is suitable for them. Even today, all the cities and villages are not located haphazardly. It has got some geographical factors for its settlement. This is and towards the north, there is a small nala where water remains throughout the year. Now, there are a number of artifacts in that area. What do we do? Whatever disturbance has taken place, it has already done. But when we archaeologists get into the site, we'll have to be very, very meticulous. We'll have to see how much artifacts have been disturbed from its original location and what has happened. So what do? We flag, we point out all the artifacts in that locality where there is a high concentration. Then we go for, these are the flaggings of each of the artifacts, and then we go for the very, very detailed plotting. Each and every artifact with a number of parameters, with geocoordinates, these are all plotted. Including each of the artifacts before picking up. We take the photograph the way it is lying, because there is implications of how much disturbance has taken place. You must have seen, if any of the stones are lying on the surface for a longer period and there is a water flow on that, so that surface will be abraded, not the bottom surface. If any of the stones which moves, all surfaces will be abraded, the way we see it on the river pebbles. So how much each of the artifacts has moved from its original context can also be determined by studying the abrasion pattern. Now, that area, when you started plotting, we could see 1, 2, 3, 4 clusters. Now, these clusters definitely shows that there is some sort of a habitation, periodical habitation, and there must have been a small band society. These are the smaller settlements. On this side, water is available throughout the year. There is a pool, dried nala, but water remains almost throughout the year. And these are the clusters. Otherwise, if you do not meticulously plot it, you won't see. Now, what we are doing, from each of these clusters, we consider as a small band, they must have occupied. What are the activities they are doing? What are the different artifacts lying within this cluster, and how it varies from each of these clusters, so that we will be knowing what it indicates. Now I'll take you to another site. The earlier, which I showed you, it's somewhere here. Now I'll take you to the inside of Hiseb Valley here, and it has got a very thick deposit of sediments alluvium. Almost 10 to 12 meter thick deposit of Acheulean. One of the thickest, like Atirampakam, you must have heard. It has got a very thick deposit of Acheulean. It's like that. Now, there is some erosion, and artifacts are getting exposed and many are already buried. So anything which is lying on the surface, we should not think that these are all disturbed. Our job as an archaeologist is to determine how much disturbance has taken place, because it's very much essential to know the disturbance process. And that's why what we did, we gridded the whole area and tried to show the slopes, because when we study each and every artifacts within this area and the slope pattern, how the artifacts are moving, whether they are moving or not, that can also be determined. Now, this area, when we did the sampling, of surface sampling, we collected more than 20,000 artifacts. And before lifting all these artifacts, because we all call it, when archaeologists, they go to the field, they do destroy the sites. But those destructions should be a scientific destruction. So what we do, we collect, before collecting these artifacts, we go for a mosaic photograph. Each of the grids have been photographed and joined together. This whole photograph of something like a couple of 100 GB file. It's a huge file. Now it's reduced to show it to you. And we can blow it up, each of the 1 meter by 1 meter grid, and see each and every artifacts like 1 meter by 1 meter grid. So you can see each and artifact, the way it's lying on the surface before lifting it. Now, after plotting it, we see their orientation. Do they follow the orientation of the slope? Now, if some of you must have seen in the nalas, rivers, where a lot of pebbles are there, we study the pebbleometry. What it says, all these pebbles, longitudinal pebbles, if the flow of the water is more high energy water environment, then it will orient all these pebbles along the flow of the water. The same thing happens here. If that shows, then we can think that many of our artifacts are getting disturbed because of this slope and energy. But we found that they are not. The different word almost remain same. Now, we wanted to understand why it happens. Then we started like ethnoarchaeology. This is some sort of a observation on the geomorphology, the present day landscape, how it forms and all that. The slope as well as energy, rainwater, that's so energy is so low that cannot carry many of these are the artifacts, cannot be disturbed. Very low energy environment, slowly these clays gets eroded and the stones come down to the same place. So this is what is happening. If the slope is less and at the same time the low energy water environment is there, artifacts won't be getting disturbed. That is what we determine. Then once we plot all these sites, what is it? Thousands and thousands of artifacts. Then we classify and see. This is one plotting, one small area where cleavers have been plotted. And their hand axes have been plotted. So we try to see whether cleavers were manufactured along with the hand axes or not. If you see in the same grid, cleavers were manufactured on one side. This area where cleavers, this is the hand axis, and here there are no hand axes, whereas cleavers are there. So in some time, probably in the past, only cleavers were manufactured on this area. We'll have to know, a lot of analysis have to be done. Like different sort of artifacts, their patterning in relation to the different artifacts. Whether if you see a lot of end flakes have been removed from the hand axis, do they coincide with the pattern of the hand axis and end flake, hand axis and side flake like that? We'll have to see and check. And this is the area, once we collected the surface for the analysis, then you go for the excavations. Because once we predict some pattern from the surface, that has to be checked, which we know that it is hardly been disturbed. So we started digging it. Our digging is so slow. This is just a 5 meter by 5 meter grid. and these are 1 meter grids each, and digging is hardly 1 centimeter each digging. Each of the artifacts, flakes, chips, everything. The moment you recover, it remains there and do a very detailed plotting parameters, and that goes to the computer in the evening when you come back to in the evening and fed it to a computer so that you can get the patterns. And this is how the artifacts are getting exposed. Very slow, it takes time. This is almost 4 to 5 months continuous, and 3 to 4 archaeologists, they work in this. And each of the grids, when we expose, things are, again, mosaic photography is done. Why we call it a mosaic photography? Each of the grids are photographed separately, then we join to that Photoshop. And then we have gone down on one level up to the earliest level. And sediment is one of the things that contains the signatures of environment and many other things, because our artifacts are within the sediments. Now, in each of the 5 centimeters, we collect the sediments for the different analysis. I'll show you some of the analysis what we do. And these sediments have got 3 types of plant remains, which is very good for the environmental interpretation. One is the phytolith, you must be knowing, because of the leaves, plants, in the plant cells, like our liver, stones within the kidney and all that. The cells also contain a stone, phytolith. So that remains, and the different species have got the different shape of phytoliths. And these organic matter of the plants completely gets rotten in the sediments, but these phytoliths remains forever for millions of years. And these phytoliths can be extracted, and the plant remains can be reconstructed. Along with that, starch grains. Starch grains, all of us, you know, that is a product of the photosynthesis, glucose sugar units like tubers and all that, that has got. And this also remains in the sediments for millions and trillions of years. And finally, the pollens. These are the 3 plant remains. This is very essential. So we take the samples, besides all the geochemical analysis, these 3 things are extracted to understand the paleo environment in a very close sequence. And of course, dating is there. We go for the dating, paleomagnetic dating, that's how we collect. And nowadays, the most recent is the cosmogenic dating. The artifacts, tools can directly be dated when it was manufactured. So both the dates, one can coincide and determine. Now, when we start digging a site, we, of course, do a very good elaborate documentation of the artifacts, but what are the sediments? Sediments we do collect, but all the sediments, we take it for the decanting. We wash it and collect one of the finest thing called microdebitas. These microdebitas are sieved and extracted. It's a very tedious job and take out. And what is microdebitas? Because our work is exactly as I told you, like forensic science. Any small things has to be picked up. Don't leave it. If you have left it forever, destroy it forever. So when you break a stone and manufacture an artifact, what happens? We have manufactured one hand axe, and this is a hammer, and you can see bigger flakes, smaller pieces, smaller pieces, and there are very, very tiny flakes. These are millions and trillions. When you manufacture one hand axe, this cannot be lifted up from the sediments. This remains in the sediments. Even in the past, if someone, prehistoric man, after manufacturing, if they clean the surface for habitation, they will be cleaning the bigger particles. But these remains, forms part of the sediment particles and remains in the sediments forever. And we can detect it, we can recover it from the sediments, and we'll be able to know when the artifacts are manufactured, where people stayed and all that. And this is how our sections are there. We study, collect the things. This is very uniform. It's a very deep trench. But again, through the mosaic photography, we'll be able to, without any distortion, we'll get the picture. Now, I told you that the errors, how we do. There are sediments. Besides human disturbances, even sediment has got different character. The area where we are working, we have got the black sediment which contain a lot of clay. And clay has got that character of contraction and expansion. When it becomes wet, it joins together, and the dry season it cracks, huge cracks, and artifacts gets into that. That means artifacts moved within the sediments from its original context. Then how to determine that? So we started studying all these cracks pattern. In the black sediment, what is the depth of the cracks, how much is wide, how big the artifacts can enter, and all those things. And in the excavations, when after the excavating it, the sediments becomes very dry, and these cracks develop. And to our surprise, even we could locate the ancient cracks. I'll show you. Even in the excavations, there is no crack here. But we could see many of the conchs are moving in a wavy pattern. So there was an ancient crack. You can see bigger size here, smaller size here. It has moved through the crack. This is not the crack which has been developed when I excavated. There is no crack. But crack was there even in the past. So from the pattern of each and every artifact, from its movement, you'll be able to know whether these artifacts are moved or not. All these conchs have been entered. They are not in its original position. That is how we study. Now, coming down to another, because we do believe, we teach the students that prehistoric people are the hunter-gatherer, there is a band society and all that. Do you have any evidence for that? Yes, of course. These are can you see all these concentrations? And these concentrations are clear indications of band societies, occupation, say a couple of months or one season, like that. Now, it has got a very good implications on paleodemography. Here comes the examples. Anthropologists should come forward to help the archaeologists, because I remember there was an article published by Narrow way back in something in 60s. And that's a seminal paper which was published in American Antiquity. Who was the person who he wrote? That was hardly 2.5 pages article, but well quoted on the floor area calculation. What he did, he writes, when he collected in 60s, the hunter-gatherer, pastoral nomads, how much area they cover when they settle, they hardly got any references from the literature published by the anthropologist. What a very little he got. He propounded a theory, how much area one hunter-gatherer society they occupy when they move and when they occupy for a couple of months, how much area pastoral nomads or agriculture family. But such studies we do not have. When I looked into our literature ethnographic data, I do not get anything. We have got number of hunter-gatherer societies, but none. I cannot get any parallel. How much area for each of, because these hunter-gatherers, they move for a couple of days, sometimes a couple of months, sometimes for a particular season, for a couple of years, and for the different purposes. How these different purposes, different settlements, size varies, and the number of people occupied. That will give me some clue to understand these band societies when I look back into the prehistoric times. And in other countries, anthropologists have done even more than anthropologists. Archaeologists are now doing it, because since there's a lack of literature in ethnographic data, like Binford, some of you must be knowing about him. He is basically an anthropologist, switched over to prehistoric archaeology. He started studying these floor area calculation and all that in Nunavut archaeology, Eskimos, and many other hunter-gatherer societies. But we don't have, nothing has been studied in our country. Here, this site is one of the unique sites, because we have got large size, which you call giant course, lot of, because very close to the resources, and it has got excellent hand axes, cleavers, and all that. Here we have noticed many of the hand axes and other things with tanked. Probably many of the hand axes were hafted, cleavers were hafted. Such evidences we have got. Now, besides studying these artifacts, we do study, because we'll have to keep some track in geology. We started studying the different weathering pattern of the different rocks that are available. Just look at it. All other, these are all sandstone quartzite. Flaking pattern is different. Here you see huge flakes comes out. I'll show you the implications. In one of the areas where the artifacts are, all the sites are located in the Deccan Trap area, there are many of the hand axes cleavers, particular cleavers, are manufactured on these thermally fractured quartzites. Because these are all tested. I'll show you those subsequently. And this is how we study the weathering pattern that gives us. Then we'll have to understand the landscape. What happens in the dry season and what happens in the rainy season? How the mood of the valley changes, how the mood of the landscape changes, where water remains, what sort of floral pattern comes. And when we understand this and our sites are plotted on that and try to see in conjunction with this, we understand their movement pattern. And this is in the rainy season. That was the dry season. Water remains. This is a dry season. Water remains in the pool form, completely dried everywhere. Now in the rainy season, everywhere there is water. Water in the valley. Otherwise, in the dry season, there is no water because this is very close to the hill. Now we go, of course, it's not very, very common. We go for the aerial survey with drone, and we get such pictures because we'll have to see what happens in the landscape, in the jungle area, in the forested area. And these, when you take the photograph, you can see these clusters. They're all different. This is a clear evidence of the band society evidences. Now the second thing comes. Now each of these clusters need to be properly documented and studied in isolation. Then you compare what is the composition of assemblage here, what is the composition of assemblage here and here. Compare and see what are the different activities performed. Now I was showing everything from this area, which is very close to the sources. Now I'll take you to the other area where there is no resources. There are only sediments, black sediments or red sediments decomposed from the Deccan Trap. No quartzite, no sandstone. Here we clean, very interesting, in one of the sites, it's called Damdogri. In one of the clusters, littered with artifacts, each of these stones is an artifact, either from sandstone or from quartzite. To why we thought that why there is so much of artifacts concentrated in one cluster, we should try to understand that. So we likewise have gone for the detailed mosaic photography, and we have started plotting each and every parameters, something like more than 10 parameters. Then we started digging. You can see this line, this area is a brownish sediment, this is a black sediment you can see, which contains a lot of clay and cracks. Now, here I'll say, when you study it in detail, there is a choice of landscape for occupation and evidence of repeated occupation. Even prehistoric man during the Acheulean times, they were very well understanding the nature of the sediments, and accordingly they are occupying. For example, we will go back. Most of the occupations are in the reddish sediments. It's not clay, it's sandy. And this is very clayey. You can understand this would support some sort of a swampy area in the past and with a lot of vegetation. So these are the areas are not good for habitation, and whereas in contrast these are good. And we wanted to see whether this is reflected in the excavation or not. And we started excavating this reddish sediment, which is slightly higher. This is a schematic section, and the black sediments you can see in the contouring. This is a trench 1, this is trench 1, 2, 3, 2, 3. They are at the lower level. This area is with the black sediment. This is the reddish brown sediment. So all the habitations were here. Now we wanted to, that's one thing we could understand, that they had a preference for habitation in the red sediment because this is sandy, doesn't support good vegetation, open, they can thrive on that. Whereas this is a swampy area, but not that. But we wanted to how many times? Because they are not had a permanent settlement. They must be occupying repeatedly. Now, how to determine that? This is the red sediment, brownish sediment, the occupation, which has got a lot of artifacts we got. And this is the black sediment. We took our trenches, the very, very small artifacts, slightly upgraded and all that. Now I'll show you. When you compare the depth-wise artifacts, all these trenches, it's very interesting. You see the distribution of the artifacts in reddish sediment. It's uniformly, people are coming, going, you can see high frequency, low frequency, high frequency, low frequency, continuous. That means staying, going back to some other place, coming back and all that. Whether this is reflected in other trenches, you come down to the other trench, you go back in the red sediment, bigger size artifacts are a lot of presence. When you come down to the black sediments, only small artifacts. That means these are slightly getting disturbed, washed out and coming to the reddish, black color sediment, which is in the slope areas. So this is the black sediment is never occupied. These are the spillover artifacts from the regular habitation in brown sediment. This is the pattern. Now also, these are the hand access cleavers. This is the site where you will get 3:1, 3 to 4 cleavers as to 1 hand access. Lot of cleavers. And this is the cluster where we have got something like 4 to 5 minus, something like 30-40%. 25 to 30%, something like that, is the only hand access cleavers, predominantly with the hand access and bifaces. And when you classify the length range of hand access cleaver, they distinctly fall in 3 different groups. One is a very small size, one is a medium size, which of course we get, and there is a very, very extra large. Now we'll have to think about the extra large hand access and cleavers, which is about 25 to 25 centimeters, so quite a heavy. Then we are now thinking, working on that, can it really be used or it had some other purpose? Now, choice of raw materials in selection, it's very interesting. And this is one of the areas where I'm working. You must be knowing bolas. These bolas are the polyhedrons and all that. These we do get in Europe and Africa and all that. And this is a very, very characteristic feature in that area where I'm working. Not one, there is quite a good number of bolas is associated with the Australian. Very, very characteristic feature. And here I'm showing the cleavers that are all manufactured on thermally fractured flakes. I showed you that thermally fractured, how it's going on. Because they'll have to bring the raw material 2 to 3 kilometers away where the source lies. So they cannot lift a huge stone and bring it over here. And they cannot take a risk. So all these thermally fractured flakes are, you can notice, becomes a very fresh surface. There is no cortex in that. That cortex is a natural cortex with the fresh. And they can see even the bedding planes. So this, and another thing, when thermally fractured flakes come out, in one side you will get beautiful edges. So one can bring those thermally fractures with little bit framing. All these edges are thermally fractured edges, no retouching. Only they do some sort of a retouching on the sides and they get a cleaver. How clever they were. Their really mind was working. And another thing we have noticed, and this article has recently been published by us, by our team, in January in Current Science, we have propounded a theory that recycling of stone tools, ancestral stone tools which go back in time, was probably considered as a taboo during the Acheulean. Why do I say? There are because if you see this area landscape, they're littered with artifacts. Go back in time to Acheulean. When the Acheulean people were there, then also the whole valley was full of artifacts. So they could have very well picked up old artifacts, again recycled it with a little bit retouching, they could have used again as a tool. But that has never happened. These recycle are very haphazardly done with no intention not to get, it's a beautiful cleaver, but recycle, because recycle how we determine on the basis of their degree of patination. And this is the first reporting of recycling in any of the Acheulean sites in our country. Till date, we have not yet reported any recycling activity noticed on Acheulean artifacts. But here, all these recycled chips working is not intentional to get an edge to reuse the artifact. So this was not with that intention. Therefore, we feel that probably because the artifacts are available, they are not reusing the artifacts of their ancestors. Instead of that, they're going back to the 2 to 3 kilometers and getting new raw material to manufacture that. What's it a fact that because they could very well recognize their artifacts manufactured by their predecessors, probably they are respecting them, not touching at all. Probably that's one of the reasons why the whole area is littered with artifacts. This is a very close to another. There is another site which I speak. We call it a lithic landscape. That word is very well used by many of the archaeologists now. The whole area is littered with the artifacts. So it's some sort of a lithic landscape. And you can see such a very less 30 to 40 centimeter deposit. But this much of area has yielded 25 to 30,000 artifacts. And this is the weathered basaltic surface on which the habitation started. And you can see there are 2 different phases of occupation. And I'll take another 5-10 minutes only. And another interesting feature we have got for the first time, we have got the evidence of Acheulean dump. When they are manufacturing the artifacts, they are very sharp. For habitation, they must be clearing the surface and dumping it somewhere. And we have got the evidence of such dump. And that dump is this one, because this has been sliced like different labels. We have taken the photograph, and this is one label with the mosaic photography. It's a beautiful artifacts in that area. And artifact sculpture, the meticulous, it took something like 2 seasons, 1 year, so 12 months to excavate this area. And we have got another, the moment these are away from the resources, so they're forced to use some of the locally available basalt as the artifacts. We get weathered very fast. So we have got some of the basalt artifacts, which is not the case at Tikoda, which is close to the source. Then associated with the Acheulean artifacts are robbed hematite. Probably they must be used. You must be knowing about the Neanderthal, that skeleton was covered with the hematite color and all that. Then along with these Acheulean, we have got the bivalves, cells, and interesting feature is the ostrich eggshells. Many of you must be believing that ostrich remained only in the terminal Pleistocene when there is a dry phase. No. Ostrich right from Pliocene onwards, there are ostriches of different species. Now, when I got this piece, I had a doubt, of course, like others. Then I looked into the literature, and from Gujarat, one geologist had reported from the early Pleistocene level and Pleistocene level that there is an ostrich. And ostrich was very much there. And this is the only evidence from our country, from any Acheulean sites associated with the ostrich eggshells. Thank you. Thank you all.